All right, let's do this, everybody. Question number 4. The volume of a sphere is decreasing at a constant rate of 23 cubic centimeters per second. So how do we, let's put in the information. What do we know? We know that V is equal to 4/3 pi cubed. Pi r cubed. Now let's look at the first sentence. How do you translate the first sentence into given information? You're going to say the volume is changing, so we know it's dv dt, is decreasing, so it's negative, at a constant rate of 23. Now, how do you translate this? Cubic centimeters. So that's how it translates. That's how you read this. Cubic centimeters per second. Okay? Now let's look at the next sentence. It's saying at the instant when the volume of the sphere is 7 cubic centimeters. So you know that V is equal to 7 cubic centimeters. So cm cubed. Okay? What is the rate of change of the radius? So what do you want to find? dr dt. Okay? If you had this set up, pat yourself on the shoulder, because I'm guessing a lot of you maybe got stuck at one point, or maybe you were able to solve it. But if you were able to do this part, excellent job. Visually, what's happening, you have a sphere, and you know that the volume is decreasing. So whatever your sphere is, you know it's going to decrease. Oh God, that was terrible. It's going to decrease over time. The sphere gets smaller and smaller and smaller. So now, what is the question asking? It's saying, what is the rate of change per second of the radius? Like, how is the radius decreasing every second? You know that the volume is decreasing by 23 cubic centimeters per second every single second. That's how much volume is decreasing, but you don't know about the radius. And that's what you want to find out. So let's do it. So here, V equals 4/3 pi r cubed. Now, what are we going to do? We're going to take d dt on both sides. Okay, so we take d dt, and now we have dv dt is equal to 4 pi r squared dr dt. Now, if you're like, no, this was from the previous problem. We already took the derivative of the volume of sphere with respect to time in the previous video. So I'm just continuing with what we know. Now, do we know dv dt? Yes, we do. dv dt is negative 23. Okay. Do we know 4 pi? Do we know what the radius is? No. So let me see who, maybe some of you got stuck on this part. What is the radius? You don't know. Do you know what dr dt is? No, because that's what you want to find. But what is the radius? Now, this is where we have to do some work on the side. Here, if you know, can you find what r is? Well, let's see. If V is equal to 4/3 pi r cubed, okay? And what do you know about the volume? You know that the volume is equal to 7. If you know that 7 is equal to 4/3 pi r cubed, do you have enough information to find the radius? Yes, you do. How do you find the radius of this? Okay, what I want you to do is, how do you get r by itself? So let's see. What would be the first move? You would divide both sides by 4 pi over 3. Because, 4/3 times pi is 4 pi over 3. So 4 pi over 3. So if you were able to get to this part by yourself, big kudos. But if you weren't, I know this was a little tricky at first. So how do we actually do this on the calculator? So what we're going to do is we're going to go second y equals n over d, 7 divided by second alpha n over d, 4 pi over 3, because I want to know what that is. And that is equal to 1.2 0.671126.902, and that's equal to r cubed. Now, how do you actually get r by itself? Pause the video, or like, what are you gonna do on both sides? You're gonna take the cubic root of both sides. So now you know r is equal to, now what do I want to do? I want to take, how do I take the cubic root? Let's see. Math, cubic root. Okay, now I'm going to type in 1.671126.902. And that's equal to 1.186687798. Okay, and that's what it is. And notice that I'm not rounding or anything. Whatever the calculator gives me, I'm just going to put for now. It's only at the end when you round. Okay, so we know that the radius, when the volume of the sphere is 7 centimeters cube, the radius is 1.186687798 centimeters. Okay, now we know what r is. Now we're going to plug r into over here. So this is 1.186687798 times dr dt, because we want to find what dr dt is. Now this part is not too bad, because all we're going to do is divide both sides. Let's get another color. We're going to divide both sides by 4 pi times, whatever, this whole entire number, 4 pi times, this number here, and that's it. And that's our dr dt. So now let's just do it in the calculator. Oh boy. So second y alpha n over d, negative 23, negative 23 divided by 4 second pi times 1.186687798, and that equals, bam, negative 1.5. So dr dt is equal to negative 1.542344877. But now what do we want to do with this number? We want to round it to 3 digits, so negative 1.542. And then what is this? What are the units of measurement, right? Try and pause the video. What will the units of measurement be? It'll be centimeters per second. Okay, so what does this dr dt represent? It represents that, try and write down what it represents. It's saying every second, the radius of your sphere is decreasing by 1.542 centimeters per second. Okie dokie. Is this difficult? I think we've done more difficult things. You just have to kind of get the feel for it. All right. Now, how can you do the other problems? Let's take a look here. Here, look at the equation for a cone. And what does I guess I'll just do this in a separate video. Okay? Enjoy your day.